Today we're going to talk about conditional probability. So if there are two events, A and B, we use the notation A given B. This represents the event A given that B has happened. So for instance, let's look at the Venn diagram to the right. It shows the number of people in a group of friends who bike or skate. If we wanted to find the probability that a randomly selected friends who bikes also skates, we would look at the number of students who bike and skate out of the number of students who bike. Okay, so what will end up happening is we will focus on the bike circle, and then we will focus on the circle or the part in the middle. Okay, out of that total amount. So I like to tell students that anytime you have given that, that's telling you what your denominator should be. So let's look at a real example. So example number 1. It says here that in a survey, 55% of the respondents say that they had taken an AP course and 29% said they had taken IB courses. 40% of the students are enrolled in standard courses. So if we were to make a Venn diagram, we're going to have a circle for AP, a circle for IB. Everything else goes on the outside. 40% said they were in standard courses, so 40 goes on the outside. I do not know how many took AP and IB, so that is an X here in the middle. Remember, you always work your way from the inside out. So if I don't know how many students took both of them, then I know I'm going to put an X there. 55% of the respondents said they had taken AP courses. So the students who took AP only is going to be found by doing 55 minus the amount of students who took both AP and IB. 29% that they said they had taken IB courses. So the number of IB only will be 29 minus X. So remember, if I want to draw a Venn diagram, that means I need to know what X is so that I can substitute it back in and get my numbers. So I'm going to make my equation. So my equation is going to be 55 minus X plus 29 minus X plus the 40 on the outside. You cannot forget about them. And we know this should add up to get 100% because we're talking about percentages here. So if I combine like terms and simplify, I would have 55 plus 29 plus 40, which will end up giving me 124. And then I have the negative and the positive X would cancel here. And I would just bring down the other minus X. So I would have 124 minus X, which equals to 100. And then, of course, I would subtract 24 on both sides. So I would get negative X is equal to negative 24, which, of course, would end up telling me that X is equal to a positive 24. All right. So if I know that X is a positive 24 here, then I know that I'm going to write 24 in the center. And then 55 minus 24 is 31. So here, instead of 55 minus X, we can do 31. And then 29 minus 24 is going to be 5. All right, and I can know that everything works out because it says 55% of the respondents say they had taken AP courses. Well, if I add the numbers inside of the AP circle, I get 55. 29% said they took IB courses. If I add 24 and 5 inside of the IB circle, I get 29. And 40 students said they were enrolled in standard courses, so I'm good. All right, so now that I have my Venn diagram filled out with my regular numbers, what I can go ahead and do now is answer the question. So the questions say, find the probability that a random student had taken an IB course given that they had already taken an AP course. So this portion right here, when it says given that they have taken an AP course, what I am basically trying to find here is the probability of them taking an IB course, given that, that's what that line means, they have already taken an AP course. So I like to tell students that it tells you what your denominator is. So if I say given that they have taken an AP course, that means I'm only focused on AP classes. So the number of students who took an AP course is going to be 55%. So out of that 55%, how many of them took an IB course? So out of that 55% here, and let me highlight it so that you will see what's going on. So out of all of these students here, out of these 55% of the students, we want to figure out how many of them actually took an IB course, which would technically be where the intersection is. So that's going to be 24 out of 55%. So if I know I have 24 out of 55, just to make sure it reduces, we still get 24 out of 55, okay? So if that is the case, then that is my probability. And if you want to, you can write it as a decimal, you can write it as a percentage. It does not matter, all right? And to show you that, if we wrote it as a decimal, we will have, okay, 24 out of 55. So, of course, in 3 sig fig, we will say approximately 0.436, which is approximately 43.6%, either or. Either answer would suffice. As long as they do not say give it as a percent, you're fine. Decimal, percent, or fraction will work. And your fraction doesn't even have to be simplified, to be honest. All right, the next part, it says, what's the probability that a student has not taken an AP course given that they have taken an IB course? So I'm basically saying the probability that the student has not taken an AP course, so that's the not symbol, given that they have taken an IB course. So what we have to do here is we have to look at the IB course. So my IB course is here. So out of these students in here, how many students have not taken an AP course, which means that we will be dealing with these 5 people in here. So that will end up being 5 out of 29, because 29% took an IB course and 5% only took IB. And of course, if we do 5 over 29, we do not reduce, but as a decimal, it's going to be 0.712 in 3 sig fig, which is approximately 17.2%. All right. So that is that one. So now let's look at example 2. It says, suppose that there is a disease that affects 1 person in every 1,000. Okay. It is curable, but the treatment is unpleasant. A test has been developed that gives a positive result for the presence of the disease in 97% of the people who have the disease and 4% of the people who do not. So to represent this, I'm going to use a tree diagram. So we're going to look at the fact that we have a disease that affects one person in every 1,000. So basically, the disease is going to affect one person in every 1,000. And we know that 1 divided by 1,000 as a decimal is going to be 0.001. So if I wanted to, I can just write this as 0.001. The disease does not affect, or no disease would happen with 1 minus that, which technically is 0.999. Okay, now you can have the disease and not have the disease. So we have those probabilities, but we're going to talk about the test either being negative or positive. So if the person has a disease, they could have had a positive test or a negative test. So it says the test has been developed that gives a positive result for the presence of the disease in 97% of the people who have the disease. So out of the people who have the disease, 97% of those people had a positive test, which means that 3% of those people had a negative test. For the people who do not have the disease, the positive test happened to 4% of the people who do not have the disease. So 4% is 0.04. The people who did not have a disease and who had the negative test is going to be 96% or 0.96. So now let's calculate the probability that a randomly selected person will have a positive test. So you can have a positive test and have the disease, and have a positive test and not have the disease. So we're going to say the probability that you have the disease and you received a positive test, or the probability that you don't have the disease, and that you had also had a positive test. So when I do that, the probability that you're going to have the disease and have a positive test is going to be given by 0.001 times, because that's the word and, had a positive test, which is 0.97, or means to add that you did not have the disease and you received a positive test, which is 0.999 times 0.04. So when I put that in the calculator, I end up getting 0.04093, which is approximately in 3 sig fig, 0.0409, which is approximately 40.9%. All right. Part B, it says the probability that you're going to receive a false positive test. So a false positive test, what that means is that we're trying to find a probability that we did not have the disease and we received a positive test. So technically we have already found that part, which is here. So all we have to do is multiply 0.999 times 0.04, and that will equal 0.03996, which in 3 sig fig is approximately 0.04, because the 6 makes that 9 a 10, which makes that other 9 a 10, which bumps that 3 to a 4. So we can say approximately 0.04, which is also approximately 4%. And then part C, we want to find the probability that they have the disease given that they tested negative. So the probability that they have the disease and they tested negative, or given that they tested negative or they had a negative test. What we have to do here is we have to understand that the probability that they have the disease given that they have a negative test, that is going to be where we have to find out the different ways that they can have a negative test. Well, out of the ways that they can have a negative test, they can have a negative test two ways. They can have a negative test and have the disease, and they can have a negative test and not have the disease. So the probability of having a negative test is going to be 0.001 times 0.97 or 0.999 times 0.96. So out of the two ways that they can have a negative test, we want to figure out what is the probability that they had the disease. Well, there was only one way that they can have the disease and have a negative test, and that would be the 0.001 times the 0.03. So if we were to do that, we will put alpha y equals 0.001 times 0.03, all divided by 0.00 or 0.001 times 0.97 plus 0.999 times 0.96. And when we do that, we will end up getting that we have 3.12 e to the negative 5. So remember, that is scientific notation. And if I wrote it out in 3 sig fig, it would be 3.12 times 10 to the power of negative 5. And if we were to write it out as a regular number or a decimal, it would be 0.0000312. So that is the probability here. So we know that that probability is slim to none. And if we wrote this as a percent in 3 sig fig, it will be 0.00312%, which means that there is a very, very slim possibility that you are going to have the disease given that you have already tested negative. All right. If you have any questions, please let me know or let your teacher know, and we will be happy to assist you. Have a great day.